All right, so this is the assignment for instructions on Canvas. And if you followed along, what we're going to do right now is I'm going to use a sample one data set to run the same model. So you might not get the same results that I do, but then we're just going to follow along the process to do the association rules, the first part of our textual analysis. And a little about the data set would be that it is food product reviews on Amazon. So you might see like maybe pet food or food items like coffee, like I got in my first sample. And depending on what the sample data set has under the products, your results might show up with the same associated uh, text mining results. So first step, download this data set, any one. So I don't want you to do all of them, but you're free to do all of them, but just take one and download it and save it. But I think I have it here in my RapidMiner. So let me share my RapidMiner screen. All right. So what I've done is I've just opened RapidMiner. So the first thing you would do after you download the data would be click on import data, since we're in the new process anyway. So go to my computer because you've saved it on your machine. I usually just directly go to downloads and then save my files right there. And then look for the Excel file. I don't have it here, but you just have to select it. So you would just import it to a certain, I would usually save it to local repository and data. So you can see in my screen that I have several data sets here. This is where I usually save the data set. So the first step would be I have sample one here, which is what I'm going to use for this particular example. But before I actually import this into my process canvas, I'm going to right click on that data set and click on edit. And you can see a data editor window. But the problem when you import is that some of the columns will be polynomial. But then if you look at the data type or data values in the columns, there will be numeric or there will be text, especially these two, summary or text. These will be these are text basically, but then initially they're polynomial. So what you have to do is like right click and click on modify attribute. And then change it to where it is text. Let me see if I've changed the sample to. Click on edit. Yeah, probably I changed this one as well. But then usually if it's like polynomial here, you can right click and click on modify attribute and then change it to where it can be text and say apply. So I'm not going to change the user ID to text. But then make sure after you do this, oh well, let's just change it. And then please make sure you save the data set, because if you don't save these changes and then just drag and drop this onto the canvas and you run your process, it won't generate results. It's probably one of the reasons that if you did everything right, but then you didn't end up with any results. So that's something just you can go double check it. If you got to a point where you did not get any results, you would just go back and check your data set. All right, so first thing, here's like drop your data here, and then I need So what we're trying to do in this particular process is that I want to analyze what did the customer say about the certain or different products. So that is something available in the column text. Okay, here. Says the problem with this mix and to mine the only problem. So the customer has written some feedback on the product or his review on the product. So my intention is just to analyze this, but then you can be creative and use different filters, or you can come up with another analysis, use, oops, why I keep doing that? Use summary text. Summary text is probably just the highlight or the title of the review. And you can filter by score. That's something I'd be interested to see, if you can filter when you do select attributes or use filter. Show you here. Yeah, you can filter out your whole data set. So each data sample has 10,000 rows or 999. You can filter out examples based on a criteria. So let's add, you can add maybe the score is equal to 5 or 4, that way. You can do it. So what this operator does is it just filters out only those comments, only those product reviews which have been rated 5. All right. So we don't have to do that for the assignment, but if you want to play around, you can always do that. But if you're just following along the instructions, let's do select attributes, do the connector. And I just want to select a single attribute. So I will do text. All right. Awesome. And then once I've selected my column text, I want to process them. So I'm going to use process documents. Actually, skip the part where I install the text processor. I'm going to pause the recording for a while, but then just to check if anybody has a question, I'm going to the marketplace and installing the text what is it called, text processing from the marketplace. All right, so I went ahead, typed in process documents, and it didn't go all the way, so this just pops up. So I will take the one that says from data. So each row is considered, like the whole thing is, the whole data set is considered as data. So each row is considered a document. So we're going to do process documents from data and connect the EXA to the EXA. So when you hover over it, you can see what the input or the outlet is for. And then, did I do it wrong? Okay, probably. All right, so if I double click on it, I can go in. So now that I have selected to process my documents, I need to tell the software what to do. So what I'm going to do is tokenize, which is breaking up the whole sentence into words. So it's as simple as it gets. So, and then it's gonna filter out the non-letters. So I think this is where your Unicode characters like disappear. So they get filtered out. And then after you tokenize, then you have transform case. Okay. transform cases, where I will convert all of them to lowercase, because the results can be case sensitive. So once we do that, then we take out all the stop words. Let's do English. I haven't tried the different things like dictionary or English. I've always put English, so that's gonna do it for us. And I want to filter, or I think it's not filter. Filter tokens by length, because I want to take only those words which are over 4 characters to 25, or you can increase this number, you can play around. So there's something another I wanted to mention is the filter by content will consider, or let me add this to show it, because if you're trying to do something regarding, you know that your data set contains just reviews about coffee. So when you put it in a word cloud or you try to analyze it, the most frequently used word would be coffee. So in that situation, in my analysis, I probably would not want to see the word coffee highlighted a lot. So I would put the condition as contains string coffee and try to do invert condition, because what this operator does is that it's going to filter those tokens which contain coffee. But then my reasoning over here is like, I don't want those documents which contain coffee, so, or I just want the words to be removed. So I'm going to just take use the invert condition, just inverse my criteria. So that way, if it's necessary, you can use that operator, but for this assignment, you don't have to. All right, so we're done here. I will click on process again and go back to this. I don't need this. Okay, all right. And once I have my documents processed, I'm trying to look where I would go numerical to binomial. So what I have here is the term frequency. I think it's just binary term occurrences. That's what you have to set for market basket analysis. Let me double check. Yeah, binary term occurrences, because the processing of those documents will create vectors, and this is one of the process vector creations. We want them to be binary term occurrences because we're going to convert numerical to binomial. Right, let's convert that. So we need attribute filter type all, but because we know that it is just the column text. I need to check something here. Okay, because I think I was just looking at the instructions and I said keep text, select checkbox for keep text, and but that doesn't seem to be appearing here, so I'm going to go back and change it. But that's something where I can set the prune method. That is just when I say prune, it's just a filter criteria. I think it is. Probably the newer version has something like this. So maybe let me try to do it this way, where I set a minimum and maximum to that. All right, then I have create association rules. Hopefully that's it. Oh no, I have FP growth and then create association rules. I guess I forgot one step. FP growth stands for like frequency pattern growth, which is our concept of market basket analysis. So you can read more about the operator in the help document, or you can go to RapidMiner documentation and then look at it. And this is where I will set the minimum support to be, I don't need it 95%, but maybe 10%. Items, yeah, this input format remains the same, items in the dummy coded columns. Then the requirement is support, because this is just the way I'm telling the algorithm that I need to find that word in every document and not just the highest frequency of it as an overall. Okay. All right. So let's connect that to create association. All right. The frequency is going to association rules. You can play around. I've only given where I talk about the confidence. And this is 0.8 is like 80% of confidence. So when you get the chart where you can see all the words, you can tell by that. You can tell the confidence of the frequency of the words against each other. You can play around these values. It's just that you have to understand what they stand for, which is again available in the additional documentation, the RapidMiner community, or here in the help. If you still can't follow it, just send me an email or ask me. I'll tell you. The last part of it, I'll just connect the rules to the output, and then I can run it. Let me start with somewhere I can do 20% of confidence, which is pretty low, but you can still try. Wait a couple of minutes until it runs. Something interesting you would, if people are, whoever's interested in understanding the performance of the software or your model, you can see in the bottom the number of seconds or minutes your process is running, or you can see where my arrow is. So towards the end, you can represent this as well as one of your performance metrics of your model. All right, you can see it's running. All right, guys. I just resumed the recording. Sorry, there was a problem with the RapidMiner, and I had to close and rerun the process. So when you see the results, you can see that. Let's go to the description, and I can see the association rules. If you read from the textbook, you can see that the words on your left of the arrow are known as the premise, and the ones on the right are called the conclusion. So we can also say that it's the premise is the consequence, no wait, of a conclusion. So what we can read from here is that with a 21% of confidence, the good product words appear together in most of the documents, and the highest percentage is coffee cup with 61. I mean, this is just an occurrence of words, but then all together, they form the gist of the product reviews we got, or our data set that we have. But what I want you to explain from all of this is that this is, think about it, this is a static data you're reporting. This is not one of the predictive algorithms where you're trying to know what could be good, but then you're just trying to find out from history of product sales that how did the customer perceive or like or dislike the product. So these are the words that can help you decide that, and association rules is one of the techniques you can use to find that. Let's see, you have a question. K-means clustering. So we'll do that in the next one. But Srinivas, did you have a question?
Hello, ma'am. No, actually, I thought it was related to k-means clustering.
Oh no, we'll do K-means in a second. So we're done. We're going through assignment 4 and 5.
Okay.
So 4 is association rules, and then 5 will be cluster.
Okay.
Yeah. Once.
Sure.
Yeah. We've done here. So I need you to report this in your report. Just talk about the association rules, talk about all of them, and then what each confidence signifies. Don't just write it, and then you can make something out of this graph as well, where you can see the occurrence of coffee cup. Because basically what this algorithm has done, it has counted the frequencies of words in each document, in the sense that in each row, how did each customer talk about the product they used. And the word good is associated with flavor, taste, and it's a great taste or great product, good product. So with all these arrows, you can come up with the conclusion. So this is just like a placeholder for you to understand the association rules. Then later you can pick up this on big data. So that's the whole point, because it's just fairly small. Of 10,000 records, this data set is very small. All right, let's look at cluster analysis. So I have it ready in my process because I've done it ahead of time. But what I want to mention is that until the process documents from data, the process remains the same. But then what we're doing different is in association rules, we use the binary term frequency as the vector creation. In cluster analysis, we're going to use term and document frequency as a vector method. Do we change anything here? And prune below, prune obsolete, that is 2. All right, awesome. And cluster, I usually start with, I think I started with 10, and then I ran the model a couple of times to see how the performance of the model was using Davis-Bouldin metrics. So that's what I did for performance, and then extra two things that I added, which is probably not in your assignment instructions, is cluster prototypes. If you would like to export the clusters to an Excel file, you can use that. But for now, we're not going to do that. We'll try to run this and see what clusters we get. So cluster is an unsupervised learning. So in a way that association is telling us what are the pairs of words that come together and occur most often together relatively. But cluster is totally unsupervised, where you have no idea what kind of categories are in your text. Well, I'm just saying text because we're only talking about text analytics, but then if you have to do numbers, there are multiple things that cluster analysis can do. And one of the algorithms that the only algorithm we have for this course is the k-means clustering, because there are other types of cluster algorithms. K-means is the distance, k meaning the number of clusters. So in this particular assignment that I'm running, the k value is 5. And then you can read more in the rapid minor documentation or the articles suggested in the modules. And performance is just another operator that I'm using to know basically if I'm using the right number of clusters, or because when you see the cluster results, you don't want to have 2 big clusters and then 3 small clusters. So you need to have equally distributed, not totally equally, but partially equally clusters. And they might direct you to the possible categories that exist in the data. So I'm gonna pause just a bit until this runs. And then if you have any questions, you can just type in the chat or just talk to me. All right.
చెప్పండి అన్న, ఏమైందన్నా?
It's gonna be all right. All right. Let's see. Yeah. It's all right. 25 minutes. Maybe I said don't use. Right. Um, okay. I'm trying to look at the cluster. It usually runs for 30 minutes. So what I usually do is just like I run this and then maybe do something else. But if you want, you're welcome to stare at it. In this cluster diagram, you can see that just cluster 1 seems to be the largest. Let's go back to description and see it has 4,500 items from the total, which is less than, it's almost close to half of it. Something else I want to see. Davis Baldwin -10. I would try to, the previous models that I have run, I usually get like -infinity. That's probably what we should shoot for. But but the negative value is what tells us that it does perform better, that the larger the number, the better. So this is a centroid table that I am looking at, and when I run the clusters, what these clusters are usually telling me is that it's not like it's showing me any kind of how do I put it? Like it's just telling me a category of items that are similar to each other. So when I try to click on centroid as the cluster 1, which is cluster 0, named as cluster 0, for the first cluster, the centroid value is a distance, which has been calculated from the clustering algorithm that we used. So I would probably shoot for the highest, like sorted to descending. and then see if what do I have in the first 100 or 200, or you can, that's why I said the export option would be more feasible, where you can actually get all the words and then their centroid values as well. But you can see that the attribute food is present in all the clusters, but that's just this table. But then we're trying to understand that how far or close it is from each cluster. So the closer it is, the higher the number. I think it's based on a distance formula. So higher the number is, we would say that that particular word belongs to that cluster. So logically, you might feel like, oh, if it is 0, then it probably belongs to that cluster. So when we do the cluster parameters, we're trying to do cosine similarity, which is a little different. If we have done the nominal measures and maybe had done, I think, Manhattan distance, that's probably the reverse of cosine similarity. So just because we're doing cosine similarity, we're gonna shoot to where we look for a higher number. And I've mentioned a little more, a few more sources in the module readings for you to look at to know more about cluster or centroid table and how to interpret these results. And what else do we have here? Yeah, you can just tell me what you think these categories are, the most frequent words, and then tell me overall what is your data set talking about. And this is one of the ways we have unsupervised learning going on in text mining. But I'm not sure if anybody got to the point where you did assignment 5. But if you have, do you have any questions? I'm gonna stop recording.